Example number 3. What is the effective thickness of the gas film for the evaporation of water into air in a 2-inch diameter wetted wall column at a Reynolds number of 10,000 and a temperature of 40 degrees Celsius? And then repeat the calculation for the evaporation of ethanol under the same condition. At 1 atm, the diffusivities are 0.288 centimeters squared per second for water in air and 0.145 cm squared per second for ethanol in air. Given the density and viscosity of air is 1.129 10 to the power of -3 gram per cm squared and 1.86 times 10 to the power of -4 cm per second. Okay, so the question is asking us to find the value of ZT, right? To find the value of effective thickness. So the value of ZT. So it has given us the value of Reynolds number, and we know that Reynolds number is greater than 2100. So this is definitely a turbulent case. So how do we actually solve for this question? So let us look at. So our first step is done, right? I already know the value of Reynolds number is actually equal to 10,000. So I know that my system is in turbulence. So if you look at the question, we have actually two systems. One is water air, one is ethanol air, right? So let's say we do for A. A we classify as water air. And both of the system has a Reynolds number of 10,000. So I know that this is turbulent. So my second step is to find the value of Schmidt number. SC is actually equal to mu over rho DAB. Right? So from the question, I know that for water and air system, the value of viscosity mu is actually equal to 1.86 10 to the power of -4 gram per cm second. The density value is actually equal to 1.129 10 to the power of -3 gram per cm cube, and then my DAB value is actually equal to 0.288 cm squared per second. So most of my units are in gram, cm, and second. So when I substitute all the values here, I should get a value of Schmidt number around 0.572. So this is a definite value of a small Schmidt number, less than 430. So this is this is the value. So I know that my Sherwood number is going to be SH is going to be 0.023 times Reynolds number to the power of 0.18 times my Schmidt number to the power of 0.44. Okay, so I'm going to use this equation. From this equation, when I substitute my Reynolds number of 10,000 and Schmidt number of 0.572, I should be getting a value of Sherwood number around 31.26. Okay, so now I've gotten the value of my Sherwood number, and I also know that from our previous examples that K is actually equal to SH, right, DAB over T, right? This is the formula for K. And I also know that when we were defining our mass transfer coefficient, I know that K here KC or K, I can define it as DAB over ZT, right? We made our definition on KC here. So if you see here, I have two equations for K. So I can just write here SH times DAB over my D is actually equal to DAB over ZT. Okay, so I can rearrange my equation here. Okay, I can rearrange my equation here. I know that I can cancel off my DAB with my DAB, right? This one I can cancel off. So I can rearrange. I will get my ZT here. ZT will be equal to D over my Sherwood number. Okay, so this is one way for you to actually find the value of ZT. And when I substitute all the values here, I know that for the diameter of the tube or the wetted wall was given as 2 inch, 2.0 inch, and my Sherwood number is 31.26. 31.26. So if I do this, I will get my value of my effective film thickness. My ZT here is equal to 0.064 inch. Okay, so you can either change inch into cm, meter, or centimeter, up to you, or you can leave the answer here. So that is the first way you can find the value of ZT. Or you can just do again, you find the value of K first, and then you substitute the value of K here, and then you can find the value of ZT. Either way, you should get the same value of ZT. So this is for the first system, which is for water and air. When we have water and ethanol, okay, when we have water and ethanol, you will have a different Schmidt number because you will have a different DAB value, right? Everything else will be the same. So for B, when we have ethanol and air system, just now was water and air. So Reynolds number is going to be the same. It's going to be 10,000. Your Schmidt number is going to be different. Why? Because viscosity over rho DAB. Now the viscosity is going to be the same because we are using viscosity of air and density of air. So it is going to be the same value as this one, 1.8 and 1.12. But the diffusion coefficient of ethanol into air is different from the diffusion coefficient of water into air. So the DAB value here for ethanol into water is actually 0.145 cm squared per second. So let's just see whether it's correct or not. So the diffusities are 0.288 for water and air, 0.145 for ethanol in air, right? So once you have got this different value, you will get a different Schmidt number. If you have a different Schmidt number, you get a different Sherwood number. If you have a different Sherwood number, definitely you'll get a different ZT. So when we substitute into this equation, you should be getting a Sherwood number, a Schmidt number of around 1.14. And then by using this, since our Schmidt number is still less than 430, so we know we'll be using this same equation, right? Because it is for low Schmidt number. So you should be getting a Sherwood number of around 42.3, and based on that, you can get your value of ZT is equal to 0.047 inch. Okay, so this is the final answer. So from this question, you can actually see if you have a different system, even though you are having the same one component, your air is fixed, but since you have ethanol here, it will actually affect the diffusion pathway, the diffusion length, or your effective film thickness. So that is all for this example, and I hope you understand how to actually use all this equation.